Okay, guys, now we're going to move to angles, okay? Angle proofs. Angle proofs are treated the same exact way as segment proofs. So let's jump here. If I'm looking at this, you're going to do this on your own, but I'll give you a brief preview or a review. It gives me angle 1 and 3 are the same. We want to prove this whole angle here, AEC, is the same as DEB. So we have two small angles congruent, and they share an angle. We want it to be the bigger one. So I have two smalls. I want to make it the larger angle. We make it match. You can follow this, fill in the blank to do that. Use the same concept as you did with segments. Same thing here. You're given the large. We want to prove the smallers. That's when we subtract. I have a large. They share a piece. I have a large and one small. Subtract. But let's go back here and look at this. We're using bisecting, okay? So we have FD, we're just going to label this up. FD bisects EFC. So that gives me 1 and 2 are congruent. Well, FC bisects DFB, so that gives me 2 and 3. Well, if two angles are congruent to the same angle, they are congruent by transitive property of congruence. We just now have to formalize it. Again, we're separating the givens because one given gives us something. I want to make sure that you know this given is pertaining to what information? Angle 1 is congruent to angle 2. Definition of a bisector. Now remember, or it could be of an angle bisector. Proofs are not about proving angles congruent. That's not a thing you're going to do in real life. What a proof is about looking at an argument, setting it up logically, stating things in a logical manner with proof, with reasoning, right? So we need to know, hey, if I'm talking about FD bisecting, it gives me 1 and 2. FC gives me angle 2 congruent to angle 3. Definition of an angle bisector, 3N. And then now 1 is congruent to 3. If two angles are congruent to the same angle, the transitive property of congruence. We've gone over these two. Let's look here, right? So this is an order that is going to happen. You will be given a diagram like this where you'll have 1 and 2 as a linear pair. You state their linear pair. The reason is it's pretty simple, but we have to put it out there because you may not think of it. The reason is just definition of a linear pair. If I see two angles form a line, I can call them a linear pair, definition of a linear pair. What do I know about linear pairs? What do I know about them? They are supplementary. So once I state they're a linear pair, I can now state they're supplementary. Why? Why is that? We've done that many times on our problems earlier in the year. Yep. Linear pairs are supplementary. So the first thing I do is I state their linear pair. Then I can say they're supplementary. What do I know about supplementary angles? Yeah, they're 180. So now I say the measure of 1 and the measure 2 equals 180. Definition of supplementary angles. Notice, when I'm talking equals, I have to say the measure of the angle. If I'm just talking about the angle, I call it angle 1 or angle 2. If it's the measure and equals, I say measure. If it's just the angle or congruence, I just list the angle. Okay. Another thing I have perpendiculars. So if I'm given that two rays in this case, or two lines or segments, whatever, are perpendicular, right? The statement is they're perpendicular. If they're perpendicular, I know that it's a right angle. That ABC is a right angle because perpendicular lines form right angles. Perpendicular lines form right angles. Perpendicular lines form right angles, okay? So if I have perpendicular, I can't go right to 90. I got to say it's a right angle. You may just, all you need to know is it's a right angle. Say I want to prove two angles are congruent. If I just show they're both right angles, I can say they're congruent right here because all right angles are congruent. All right angles congruent. So once you're perpendicular, you have to state their right angle. You may stop right there and say that it's congruent to another right angle. Or you may need to know it's 90. So after I show it's a right angle, I can say it's 90 degrees, definition of right angles. So perpendicular is always followed by I have a right angle. You may go to proving two angles congruent. When we get to triangles proofs, you may use that for hypotenuse leg, right? Or after I have a right angle, I need to know its measure, so then I'll say the measure of ABC is 90. And as we have two problems here, that'll be in class, here and here. I want you to complete these two, fill in the blanks there and there.